Okay, ladies and gentlemen, welcome to Coach Hanik's protractor YouTube video. And as you can see on the screen is a protractor. Very generic, not the exact one that we use in the class, but you'll get the idea. So let's first look at some things that are actually going on here. First, you need to observe that there's a hole in that, and that needs to be lined up typically at the origin or at a point where you're looking to find the angle, which I'll demonstrate in the next slide. The next is a zero line. Actually, let me go back to the protractor hole. On our protractors in class, there's typically a hole above, and you might see a horizontal and a vertical line. That is going to be the same thing as the hole that's on this protractor. But let's go back to the zero line now. The zero line means if you follow that, the hole in the protractor, if you follow it across, it goes to 0. It's the same thing with the other protractor that we have in class. If you see that, just you follow across left or right, it'll go to the 0 line. And then with that, when we follow the 0 line, whether it be left or right, we notice that there's two sets of numbers. And I'm just going to circle it right here. You can see on the outside there's a 70, and on the inside there's 110. And clearly they're not the same number, so what does that really mean? Well, if you look at this, if we follow this again across, and we get to the 0 line, as we go on the inside numbers, looking on the inside, as we go up, it's 10, 20, 30, 40, 50, 60, 70, all the way up to 100. And that, I'm sorry, all the way up to 90. And that kind of makes sense, because if we did that, we'd get a 90-degree angle. If we look at the numbers on the outside, we're going from 180 to 170, 160, 150, 140. You get it all the way back to 90. It all depends on how you want to look at the protractor. It'll determine at what angle, and that's what the next slide is going to be. So, looking at the protractor here, we have 4 diagrams, and it says find the angle between the two vectors. Notice that these vector diagrams are not drawn in tip-to-tail format. We're not worried about tip-to-tail format for this particular slide. I would like you just to find out what the angle is. So I'm looking for this right now. What is theta? What is that equal to? Well, the first thing we gotta do is take our protractor and bring it over here. And if you can see, I'm going to line up that hole in the protractor right where the origin is. And now I have created the 0 line of the protractor, and the vector is on the same line here. And that's beautiful. So I'm going to follow it up. I'm going to use the inside numbers here of 10, 20, 30, 40, 50. And it comes out to be 50 degrees. Therefore, theta equals 50 degrees for this particular diagram. All right, let's continue. Take this over here. I'm putting it at the origin right now, and I notice that this is slightly off. If I was to follow this line up, it does not go right to 90, but it's off by 1 degree. So we're just going to let that slide here, and I'll explain to you in a second why. Well, first, if I want to measure an angle using the protractor like this, we can do it 2 ways. You can count from left to right, meaning this way, or right to left, meaning this way. I'm going to do it the right to left, so let's check it out. We go 90 to 80 to 70 to 60 to 50 to 40 to 30, and it looks like there's 2 more spaces. So we have 10, 20, 30, 40, 50, 60, and maybe it's 62 degrees so far. All right, so keep that in your mental, in your mind right now. And let's check this. I'm going to erase this because I'm going to change the protractor. I don't normally do that with the protractor. I do it slightly different. So I'm going to take the protractor, and I'm going to actually turn it on its axis so that the 0 line follows one of the vectors, like so. And what I mean, if you're not sure what I still mean, is that now this vector is lined up on the 0 line. I now count over, and I notice it says 60 degrees. Well, if you remember, the old answer we just got was 62 degrees. Well, are they right? What's right? Who's right? Well, according to New York State Regents exam, they typically give you plus or minus 2 degrees. So if the actual number is 60, and we got 62, both are considered acceptable. And on the low end, if I was to measure 58 degrees, that also would be acceptable. All right, let's go back and measure the other 2 really quickly. Take the protractor here, rotate it. Oops, too much. Okay, that looks about right. And I'm going to follow it up here. And I got 10, about say 19 degrees. Theta equals 19 degrees. Don't know what happened with that one, but theta equals about 19 degrees. And so that's what you get. So again, plus or minus. If the number came out to actually 20 degrees, we're still in that. Let's take our protractor one more time. Line it up here. Looks pretty good for me. And I'm going to count again. 10, 20, 30, 40. Ooh, theta looks like it's 45 degrees. So do not be afraid to manipulate the protractor, or better yet, you could always move the sheet of paper that the diagram is on. It is very challenging for me to do that on the screen right now, but there's nothing saying you take that piece of paper and rotating it to whatever makes sense to you. What I mean by that is that we have these two vectors here. If I was to grab this and rotate it, let's actually see if I could do that here by removing the protractor. All right, I can't grab both of them right now. But if I could, I would rotate the whole thing and then actually make one horizontal, if that makes sense to you. All right, let's check out a question here. It says, below is a diagram of two concurrent forces acting on an object. Determine the magnitude and the direction of the resultant. So we have a 5 Newton and a 10 Newton, and I'm going to be honest with you, I don't think that looks right. So let's check it out. Because I don't have a scale here, we're going to make up our own scale. I'm going to take that that ruler here, rotate it, try to line it up. Oops. And according to this, we're going to change our numbers here. I don't agree with what the diagram is. I'm going to actually change this. I think this might work a little bit better, and I'll have to do some math. 1 centimeter equals 1 Newton. So therefore, if I count here, that's 12 centimeters. I'm going to cross off 5 and say that this is going to be 12 newtons. And I'll have to change a little bit, but that's okay. And then I'm going to now measure the bottom one. Oops. Actually, I'm going to get rid of that line anyway. This way it's not in my way. And this one looks about 20. My cutoff line right here. Oops. My cutoff line right about here. I'm just going to say it's 20. And that might be off a little bit, but that's all right. This is just quick and easy. So I have my two vectors. One is going to be 12 newtons, and one's going to be 20 newtons. So I'm going to take the ruler out of the way because I don't need it anymore. And I need to bring my protractor in here because I need to know what angle is between the two vectors. Lining it up, I clearly see that it is a 30-degree angle. Therefore, I'm going to move the protractor away. I'm going to say and write it down here that theta equals 30 degrees. And here's why I'm going to do that. First, I know that this diagram is not tip to tail. We must create that. So I'm going to highlight the blue one, and I'm going to move it, if I can grab it, over here to that point. And I'm lucky because with this, being that I just moved it so easily on the computer, it kept its angle. But let's make sure that it actually has the correct angle. So I'll bring that up, line that at the origin, and it's very close to that 30-degree angle. And so I'm going to remove the protractor here. I now can say that if I was to extend this line here, that this angle is 30 degrees. And so that has now allowed me to do one thing. Now I'm going to freehand this. It may not be perfect, but I am now in a tip-to-tail format. We have our 12 Newton vector and our 20 Newton. So if I connect the two, something like this, that's my resultant. And I want to actually calculate that and measure it. First I'm going to actually measure it, and then also I know that this angle is going to be 150 degrees. I know that because any straight line is 180 degrees, and if we have an angle that's 30 degrees, and I subtract that 30 from 180, I know that I get 150 degrees. So I'm going to erase some stuff here so that I can continue to do this here. That was 12 has been moved. The tip to tail has been removed. I'll even get rid of the scale because I want to draw some things here. And let's see if I can actually get this out of the way here. Well, we're just going to have to leave it there. All right. So, quick thing we could do is grab the ruler, line it up, and see if we can get the angle here. Okay, see if we can get an angle here. Okay, this is not going to allow me to do it. And that's perfect, actually, because that leads me back to the math part. Let's check out how we do this. I mean, it was clearly longer than the ruler, so that's one great thing. So we're going to go back to law of cosines, which is c squared equals a squared plus b squared minus 2ab cosine c. C squared is what we're looking for. A squared is going to be 20 newtons. I'm going to leave that units for time here, squared, plus 12 newtons squared minus 2 times 20 times 12 cosine. Well, we're looking for the angle opposite of the resultant here, so I'm going to put it in here 150 degrees. Make sure you calculate in degree, and I'm going to get a c squared and a c answer. If you just give me a second, I'm going to calculate this. So I get so far for c squared to be 80.36. And now I'm going to take the square root of that. And I have an answer of 9. And I'm going to say to you right now that that does not make sense. So something is wrong here with my math. So let's do this all over again. Let's do it the long way here. Erase this here. C squared equals 20 squared is going to be 400. Plus 12 squared is going to be 144. Minus, we have 2 times 20, which is 40. 40 times 12 is going to be 480. Cosine 150 degrees. First thing I'm doing is plug in my calculator. I'm going to say that it's going to be cosine 150 degrees. I'm going to times that by 480. I'm going to get an answer of negative 400, and I'm going to round off to 416. On the left-hand side, I'm going to have an answer of 544. And that's still equal to c squared. So c squared equals 544 plus, or minus, I'll do it minus, they'll do it your way, minus negative 416 gives me an answer of 960. I know that's squared, so I'm going to square root this. And then C equals the square root, second function x squared, of 960. And that gives me a 30.9 newtons. And that does make sense. I'm glad I made that mistake. All right, and again, if I took the ruler and brought it close, we know that it goes 24, it's longer than 24. So 30.1 actually newtons looks a lot better and more accurate. I'm going to erase all of this. So you could pause if you need to. And the reason I'm going to erase is because we need to find an angle. So while I'm going to remove this, and let me erase all of this. In fact, I'll just erase this and rewrite it. Here we go. This was R. Okay, so the next thing is to find theta. How do we find theta? And that is the law of sines. So we have sine B over B equals sine C over C. Now the reason I'm using sine B and sine C is because the blue segment here I'm going to call B. And the R, which is the resultant, is also equal to C. So this line right here and this line right here is what I'm referring to. And so let's start plugging in here. Sine B means the angle opposite of segment B, which is unknown. This is what we're looking for. Line B is 12 newtons. Next, I have sine C, which we calculate the opposite angle of the resultant right here again, 150 degrees. And C we calculated as 30.0, I'm just going to say 30.9 newtons. And now I'm going to have sine B equals 12 newtons sine 150 degrees over 30.9 newtons. And let's see what that actually comes out to be. So we have right now is sine B equals 0.194. I'm now going to press second function, this is the blue button, sine, well, now I'm going to have sine to -1, and press second function again, and on the bottom next to the enter is a little negative sign, and above that says answer. Press enter, and I'm going to have 11.2. B equals 11.2 degrees. Remember, degrees has to be there. This is a unit. This is a unit. So our final answer is resultant equals 31, I'm going to round off, newtons at an angle of 11 degrees north of east. And that was the final answer for that one. All right. Let's check out the last question here. I wrote here, a sailboat is sailing, can you believe that? LOL. At 18 meters per second west. As it is sailing, it is affected by a current that is moving in a southwest at an angle of 55 degrees measured from the axis at 10 meters per second. Find the resultant. So I'm going to quickly just do this. I'm not going to draw this to scale. I don't want to spend too much time on that. We're going to do it the calculation way, or calculate the answer. So let's check out what we have. First, I have my compass. And we're going to take the sailboat, and it's going to go 18 west. Remember, a lot of people make that mistake. West is left for us. And then it's going to sail at a southwest which is going to be in this general direction at a 55 degrees measured from the west axis, and it's going to go for 10. So this is 10, and this angle here should be 55 degrees because this is the west axis, and it's going to be below that because we're on a southwest direction, and our general resultant is going to look like this. So let's look at this here. If that's 55, we know that this angle is going to be 180 minus 55, and it gives me 125 degrees. And by using law of cosines, I know that c squared equals a squared plus b squared minus 2ab. C squared equals, we're going to use lines A, which is 18. I'm going to leave that units, squared plus 10 squared minus 2, 18, 10. And I have to apologize because I wrote the equation. I forgot the equation. Cosine C. So I got to add that. Cosine, and we said that was 125 degrees. So let's do some math here. 18 squared, I believe, is 324 plus 100 gives me 424. And then I have the right-hand side is going to be, let's see, negative 206 and 0.5. I'm going to say I'm rounding off here. Well, those two numbers are going to get added. So we're going to say 424 plus 206 point 0.5. We're going to add those up. Gives me 630. C squared equals 630.5. Here again, it's not allowing me to do this. I'm going to square root, and I'm going to get C equals 25. And that is going to be meters per second. All right, so I have R equals 25 meters per second. And it kind of makes sense because this line is 18 meters per second long. If I was just to kind of swing that line on an angle, it does make sense. It's much longer than that, and it's much longer than 18. So 25 does make some sense. Well, I'm going to erase some of this here because I do want to find the angle now. So let's try to erase this and not lose any important information. And we're now going to do sine B over B equals sine C over C. Sine B is what we're looking for. It happens to be this angle right here. And B itself is 10 meters per second equals sine 125 degrees over 25 meters per second. So I have sine B equals 10 meters per second sine 125 over 25 meters per second. And let's see what that comes out to be. Comes out to be sine B equals 0.327. 0.327. B equals sine negative 1, 0.327. And I get an answer of 19 degrees. B, oops, not going to work here. Okay, B equals 19 degrees. And that makes sense. It's a small angle. Again, my diagram is not drawn to scale. Hope this was helpful. Please rate this video. Let me know if there's a mistake or what you like or didn't like, and if I could help you in any way. All right. Have a wonderful day.